Hi, good morning students. In the previous last class, we have discussed regarding speed and we will be discussing regarding types of speed. So in the last class, we have learned regarding speed. What is the speed? The rate of change of distance per unit time. So speed is equal to distance by time, and speed is a scalar quantity which has only magnitude but not specified direction, and its dimensional formula is m0l1 t power minus 1. And so we have seen regarding speed, and after that we have seen like uniform speed. If an object covers equal distances in equal intervals of time, then that is called as uniform motion. So, you see, I took one example. A boy covers 2 meter in 5 seconds from A to B. Again from B to C, he covers 2 meter in 5 seconds. Again from C to D, he covers 2 meter in 5 seconds. So, he covered equal distances in equal intervals of time. That's called as the uniform speed. So, now we will discuss regarding non-uniform speed. See now, that's like equal distances in equal intervals of time. But here, unequal distances in equal intervals of time. Suppose a boy, okay, he starts from A and he reaches to point B by covering 2 meter in 5 seconds. Okay, from B to C, the total path is like this, A, B, C, D. Okay, from B to C, same like 3 meter he covers in 5 seconds. Again he covers 4 meters in 5 seconds. But he took the same intervals of time, but he covered unequal distances. So, if an object, like if a car covers unequal distances in equal intervals of time, that's called as a non-uniform speed. Or a man covers unequal distances in equal intervals of time, that's called as the non-uniform speed. Or I can say like this also, 2 meter, and even here also 2 meter. Instead of 5 seconds, here he took 6 seconds. Instead of 6 seconds, he took 7 seconds. Now I can form the sentence like this also. If a man or if an object covers equal distances in unequal intervals of time, that is also called as the non-uniform speed. Okay, so now it's a definition of non-uniform speed is what? If an object covers equal distances in unequal intervals of time. That is called as non-uniform speed. And what about SI unit? Here non-uniform speed also same. Non-uniform speed is equal to distance by time. So what about the SI unit? Its SI unit also meter per second. Its SI unit is same. Meter per second. What about CGS unit? That's also same. CGS unit, that is centimeter per second. Remember, the CGS unit is also called as practical unit. So in the examination, they may ask you, write the dimensional formula of non-uniform speed. You'll write m0, L1, t power minus 1. Sometimes they may ask the question, what is the practical unit of non-uniform speed? So don't get confusion. CGS unit is same as practical unit. Next, dimensional formula, same as speed, that is m term is absent. Meter means L term is there, one term, and second t power minus 1. So what about this? I'm just telling it covers a distance from A to B, B to C, C to D, like that. I did not mention any specified direction here. So I can say it is a scalar quantity. It's a scalar quantity. Right? Now we have learned speed, uniform speed, non-uniform speed. Now coming to average speed. Suppose same example you take. So here A to B, B to C, C to D. Okay, from A to B, from A to D. If I want to calculate distance, what I need to do? AB plus BC plus CD. Total distance I have to count. 2 meter, 2 meter, 2 meter. Okay, and total time I have to take 5 seconds, 5 seconds plus 6 seconds plus 7 seconds. It become 6 divided by 18. 6 divided by 18 means 1 by 3 meter per second. So here, if I want to get average speed, it is the ratio of total distance to the total time taken. If an object covers total distance, it's a ratio of total distance by total time taken. Okay, average speed is total distance by total time taken. Average speed is equal to what? Total distance by total time. This is V average. V average means average speed. Okay, average speed is denoted with the letter of V. So V average is equal to total distance by total time. Average speed SI unit is meter per second only, because the distance by time, total distance by total time. Distance is measured in meter, time is measured in second, and its CGS unit is centimeter per second, and dimensions are m0, L1, t power minus 1, and it is a scalar quantity, same as that of speed, average speed. See, if you take the marks in your annual examination, suppose 6 subjects are there. So if I ask you what's your percentage, what you will do? You will add all the 6 subjects and you divide with the 6 number and you will say it's my percentage. Like that. So total distance AB plus BC plus CD by total time taken to cover from A to D. So if you do that, you'll get average speed. Now coming to instantaneous speed. So what do you mean by instantaneous speed? Suppose a car is moving. So I'll ask you, what is the particular time? I'll mention at 0 second, where is the object? At 8 second, where is the car? Okay, where is the car? In the sense I'm talking about speed. So at 8 second, what is the speed of the car? At 12th second, exactly at 12th second, what is the speed of the car? It means particular interval of time. So speed, average instantaneous speed is what? Instantaneous speed is speed of an object at a particular instant of time. Speed of an object, speed of an object at a particular instant of time. Okay, this is called as instantaneous speed. If anything, object is moving, a man is walking, or whatever the things are moving. Suppose if I ask you by mentioning the time, particular time, t is equal to 0 second, what is the speed of the object? Or at t is equal to 4 second, what is the speed of the object? And so on. Like that, if I mention the particular time, then that is the instantaneous speed. Speed of an object at a particular instant of time is called as the instantaneous speed. And instantaneous speed is having the SI unit, same meter per second, CGS unit, centimeter per second, and its dimensions m0, L1, t power minus 1, and it is a scalar quantity. And here the formula comes out to be delta V. Here we have to take a limit delta t, because very small intervals of time we are taking. So delta t tends to limit delta t tends to 0. It means very small interval of time. Then V average is equal to delta V by delta S, because we are representing this distance in S. So delta S by delta T it is. This is about instantaneous speed. Now coming to the new term velocity, because we learned about displacement. So now coming to velocity. So what is velocity? Velocity is the ratio of displacement by time, or I can say rate of change of displacement per unit. Displacement by time, if you want to get the ratio of displacement by time, that's called as the velocity. See here distance by time, speed. Here velocity is displacement by time, but it is a scalar quantity. Velocity is a vector quantity because it has both magnitude and as well as direction also. So now I can say a boy moves in the east direction. He covers 2 meters in 2 seconds. He covers 5 meters in 7 seconds. Like that. I have to mention the direction also. So velocity is the rate of change of displacement per unit time. The rate of change of displacement per unit time. I can say velocity is also represented with V only, but I will take like this because a straight line with arrow indicates it's a vector quantity. V is equal to displacement by time. Displacement is measured in terms of meter and time is measured in terms of second. Meter by second, or I can say meter per second. This is the SI unit of velocity, meter per second. It is also having meter per second. So what is the difference? It is a vector quantity. Here we are taking displacement. You know what is displacement? Shortest distance from between initial to final point. And now coming to velocity, we have types here also. In velocity we have 4 types: uniform velocity, non-uniform velocity, instantaneous velocity, and average velocity. So now uniform velocity. here, what about the dimension? It is a vector quantity and its dimensions are m0 l1 t power minus 1. Here its dimensions are m0 l1 t power minus 1. Dimension formula of V is m0 l1 t power minus 1. Uniform velocity is what? If an object covers equal displacements in equal intervals of time. So, if it covers equal displacements in equal intervals of time, then that is called as the uniform speed. Equal displacements. If an object covers equal displacements in equal intervals of time, that is uniform speed. So its dimension is also same, m0 l1 t power minus 1. It is a vector quantity. It has both magnitude and direction. And uniform velocity. In this uniform, if a body is moving with uniform velocity, then acceleration will be 0. So we will discuss what is acceleration. So uniform velocity means a body covers equal displacements in equal intervals of time. Coming to non-uniform velocity. Non-uniform velocity. Suppose you come to the same example, only the thing is I just need to mention the direction. So if a boy covers 2 meter in 5 seconds, 2 meter in 6 seconds, 2 meter in 7 seconds, I'll change the direction. Just he covers like this. He moves in a east direction. After that, it changes its direction. He covers another 2 meters in north direction. So suppose like that. Okay, but the thing is what here? Equal displacements. That is uniform speed. Non-uniform speed means unequal displacements. I can say here 3 meters he covers and 5 seconds he'll take. So here what happens? See here from A, B, C. Total A, B, C if you want to take. Then here in the east direction. Then in the north direction. Then what happens here? Equal, unequal displacements in equal intervals of time. Then that is called as non-uniform speed. Unequal displacements in equal intervals of time. If a body covers unequal displacements in equal intervals of time, then that is called as non-uniform speed. Same dimensions, m0 l1 t power minus 1. Its SI unit is meter per second. Radius unit is centimeter per second. It is a vector quantity. Okay. Then coming to the average velocity. Average velocity. Total displacement by total time. So average velocity is what? Total displacement by total time. If an object covers different displacements, I have to add. If I want to get what is the average velocity, then I need to add all those things and I have to divide with the total time taken. Then that is the average velocity. Then instantaneous velocity. Instantaneous velocity. Instantaneous velocity means what? velocity of an object at a particular instant of time. Velocity of an object at a particular instant of time. Okay, its formula becomes like this: limit delta t tends to 0, v equal to delta s by delta t. Why I have taken this a straight line with arrow? It indicates that it is a vector quantity. Displacement is a vector quantity and even velocity is also vector quantity. So now I think you understood the speed and types of speed. So in the next class we will continue. If you like this video, share to your friends and like it. Thank you.